Okay, so let's take another look at factoring by grouping. Um, we're going to look at number 9 on your worksheet, which is 14x cubed plus 6x squared plus 35x plus 15. Okay, now factoring by grouping is an important step on the way to factoring quadratics when you have something besides 1 as your leading coefficient. So here we go, factoring by grouping. I'm going to group these two together. I'm going to group these two together. That's why it's called factoring by grouping. And then once I've grouped them together, all I'm going to do is factor out the greatest common factor. Okay? I start by looking at, so factor out the greatest common factor of the first group, and then factor out the greatest common factor of the second group. So the first group, I'm looking for what is the greatest common factor between 14 and 6. And that's going to be 2. Okay? And then, of course, I also need to know what is the greatest common factor between x cubed and x squared. And I'm looking at these powers when I see that. And the smaller of the two powers is x squared, so that is what we're going to factor out. Both of them have at least x squared in them. So it's 2x squared on the outside. And then on the inside, remember, there's going to be a binomial on the inside. 2x squared times some number is going to give me 14x cubed. Well, 2 times 7 gives me 14, and x squared times x gives me x cubed. So the answer is 7x. 2x squared times some number, looks like I've got a plus there. I'm going to put a plus here. 2x cubed times some number is going to give me 6x squared. 2x squared times some number is going to give me 6x squared. Well, that number is going to be 3. Okay? Then I'm going to do the same thing with this. Okay, there's a plus because they're both pluses, so I'll put a plus here. That plus is super important. Okay? Make sure that you put a plus or minus here, whichever is the thing that is appropriate. And then what is the common factor between my 35 here and my 15? I think it's 5. I think they both divide by 5, right? There's no x on this one, so it's just 5. 5, okay, times, I guess, 7x. And then 5 times 3 is 15, so 7x plus 3. And then look, the thing that I wanted to have happen happened. The 7x plus 3 and the 7x plus 3, they match. So that means that this can be factored by grouping, and we can finish the factor. So I'm going to take the things that are outside of the parentheses, and I'm going to put it here. 2x squared plus 5. That's what's outside of the parentheses. And then the thing that's inside of the parentheses is going to be my other factor, 7x plus 3. And I'm done. This is what it looks like when you've factored something by grouping. You end up with the product of two binomials, just like before. Okay? So let's take a look at another one. I was going to try and scoot this off, but I don't know if I can do that. So instead, what I'm going to do is I'm going to just go ahead and just clear the screen. Okay, so let's look at one that has some minuses in it. Let's look at number 11 as well. Okay, so number 11 says 5n cubed plus 15n squared minus 4n minus 12. Again, every time you factor by grouping, you're going to make two groups. Here's my first group, here's my second group. Then I'm going to factor the greatest common factor out of this binomial. Looks like it's 5n squared. 5n squared times something equals 5n cubed. I think that's going to be n. Plus 5n squared times something equals 15n squared. I think that's going to be 3, right? Because 5 times 3 is 15, and then the n squared goes over. Now in this case, since this is a minus here, since they're both minuses, I'm going to factor out minus 4. Okay? 4 goes into both. They both have minuses. Let's factor out minus 4. Minus 4 times what is minus 4n? Well, times n is minus 4n. Minus 4 times what is negative 12? Minus 4 times positive 3 is negative 12. So I've got, again, this thing that I had wanted, which is this binomial matches that binomial. And then I can take these two guys and put them in their own set of parentheses, 5n squared minus 4. And then my other factor is, boop, boop, n plus 3. And I've done it. I've successfully factored this polynomial in 4 terms into the product of two binomials. And that is factoring by grouping.